everybody. Good morning, and thank you for joining us today to learn more about the Amazon Simple Workflow Service. I'm Balan Subramanian, Product Manager for the service, and with me today from the Amazon SWF team are Maxim Khatib, Rick Sears, and Shrikant Satyanarayana. Today's webinar will consist of a 30 to 40-minute presentation, followed by a question and answer session. You'll have the opportunity to have all your questions answered by the very folks who designed and built the service. As you think of your questions, please type them into the questions section of the GoToMeeting panel, and we'll try and answer as many questions as we can right after the presentation. So the primary purpose of Amazon SWF is to enable applications that scale well, are resilient to failures, and are truly distributed across execution environments. With Amazon SWF, you can run application workflows and business processes in the cloud in the scalable and reliable manner that you would expect from any AWS service. SWF gives you durable distributed state management, and you can use SWF from any programming language because it's a web service and there are AWS SDKs that support many programming languages. We also provide a programming model and framework called the AWS Flow Framework that helps you build applications using Amazon SWF. So what are the different use cases in which you can use Amazon SWF? You can use SWF to dispatch tasks to application components. And when you want to coordinate application processing that's distributed across several components. SWF helps you implement ordered execution of application steps. And this ordering can be as simple as a plain sequence of steps, or it can be something complicated which is based on conditional logic, which may even involve some runtime state. SWF helps you manage the application state during distributed execution. And for use cases where you require periodic execution, say, for example, you want to send out a calendar invite or a calendar reminder at some point in time, SWF gives you capabilities such as timers to help you do that in a reliable, auditable manner. Finally, when you're writing programs that involve asynchronous invocation and that need event-driven execution, Amazon SWF and the AWS Flow Framework together provide a comprehensive solution that is also easy to use. So let's talk a little bit about some of the reasons why we built Amazon SWF. As we looked at how applications are being built, we found that almost all applications, even the simplest ones, require some coordination and state management. And when we looked at different kinds of applications, from simple business processes to very complex order processing systems and distributed applications, we found that almost all the applications have some kind of workflow in them. We also found that orchestration was a fundamental need for such applications and business processes. And as these business processes get more complex, and as these distributed applications get more distributed, we find that the fundamental capabilities pose difficult challenges to developers. What we also noticed was that developers and businesses were trying to address these problems by building their own solutions, or sometimes using solutions that really weren't designed to solve these kinds of problems. And they had issues with scaling their custom-built solutions or products that they were using for the orchestration capability. Developers also lack programming models that help them think about application tasks. Like, there are many programming models available for distributed programming, but we didn't find one that was suitable for programming your application tasks. We wanted to provide a scalable, reliable service in the cloud so that developers can focus on building their applications. And the result is Amazon SWF. We also looked at some of the emerging needs that developers have in building applications. We found that more and more developers were using asynchronous interactions and a loosely coupled design in their applications. This, of course, gives them advantages such as better scalability and fault tolerance, but it's also difficult to do. We also found that many applications now have a need to run across data centers and clouds, be it because enterprises want to perform a gradual migration to the cloud, or there are some security issues that require some part of the applications to run within a private data center, whereas the rest of the applications can take advantage of the scalability and the cost efficiency that comes from using a public cloud. And in general, this is difficult to do with existing solutions. We also found that developers want to go beyond elastic scaling, that is the ability to have infinite resources or very large number of resources available to them. And they wanted to go beyond that and scale in an efficient manner. And they need features such as selective scalability in their applications. So what does Amazon SWF give developers for building cloud applications? Using SWF, developers can build applications with components that run anywhere. That is, they can be distributed across data centers or multiple clouds. The components can run at any time. They can keep running continuously, or they might come up at some point in time like a batch processing system and perform the processing and then go away, and even intermittently, such as mobile devices. We want to encourage developers to think about tasks in their applications and not about low-load constructs such as messages. We would like developers to focus on their application logic and save them the development effort that comes from having to build a coordination platform to run their applications on. Using SWF, developers can take their applications to market faster because they have a ready-made coordination infrastructure on which they can run their applications. And they can scale gradually and pay only for what they use. As we'll see later in the pricing for Amazon SWF, it's based on a pay-as-you-go model, so there are no high upfront costs. Developers can also structure their applications as multiple components that are interacting through Amazon SWF. And what this gives them is the ability to scale these components selectively so that when they have a high amount of load for their application, they don't have to scale the application as a whole, but can identify specific bottlenecks and scale only them. And of course, using Amazon SWF means there is fewer infrastructure and fewer administration costs. This is because developers no longer have to run their infrastructure for orchestration, but focus only on the infrastructure and administration of their applications themselves. On the other side of the spectrum, Amazon SWF also provides a reliable, durable foundation for running business processes. When using Amazon SWF, there is elastic scalability for your business process executions. But more importantly, you can use Amazon SWF as the foundation and build tailor-made implementations for different kinds of business processes where you can add your own value on top of Amazon SWF. You can start with minimal upfront costs and scale in an economical manner. And as before, you can remove infrastructure and administration costs. It is also easy to leverage SWF from your existing toolsets and modeling frameworks simply by using the Amazon SWF API and building adapters between your toolsets and SWF. What we have seen is that many customers are already starting to build such integrations with existing frameworks that are well established for building business processes. With SWF, we really want to drive innovation in this space. And we are really looking forward to helping our partners and customers build innovative solutions in this space that weren't possible before, be it for technical or economical reasons. Let's take a simple example to walk through Amazon SWF. The use case that I'm going to use today is a video transcoding application. And if you look at this application, it's a very simple workflow. Each execution starts, and it's provided a URL of a video to be encoded. The next step is to actually encode the video, and then the encoded video needs to be protected with DRM. And finally, the encoded protected video is saved in a location that's accessible to the user. So in building Amazon SWF, we encourage developers to think about the various components of their application that perform actual work, like in this case, the workers that perform encoding and the workers that perform DRM addition, but also to think about their application flow logic and encapsulate that within a decider. So all of these are pieces of code that developers can write in any programming language. In addition to this, there is usually a piece of code or a component that kicks off workflow executions. In this case, we are assuming that there is a web server front end that accepts the video URL from a user, and it starts the execution with that URL. And also, as you can see from the picture here, Some of the workers are running on the cloud, whereas others are running behind firewalls and talking to SWF over simple HTTP calls. So the decider and the workers talk to SWF through a special form of polling called long polling. Long polling removes some of the complexity in figuring out the frequency of polling and balancing that with the latency needs of your application. The way long polling works is that when a worker or a decider performs a poll request, Amazon SWF will hold on to that poll request for up to 1 minute or until a task is available to be handed to that worker. And Amazon SWF also creates task lists based on type names provided by the worker and the decider. You can think of task lists more like queues, but they are managed by SWF, and the placement of tasks within those task lists is coordinated by SWF. So to walk through an execution, the web server frontend makes an API call to Amazon SWF to start a workflow execution of a particular type. In this case, it's a video transcoding application workflow. For each workflow execution, Amazon SWF creates a record which it maintains in a consistent manner throughout the execution and even after the execution completes. Everything that happens in that execution is recorded in this history record. So to start with, when the workflow execution starts, the input data provided is recorded in the execution history. Whenever the execution history changes, Amazon SWF sends a task to the decider. The decider now looks at the history, and it can drive the application logic. So at this point, the decider looks at the history, and it figures that the execution has just started, and a video URL is available to be encoded. So as per the logic of this application, the next step is to encode the video. The decider returns a decision to schedule the encoding of the video back to Amazon SWF. SWF adds this as a task to the encode task list, and this task is then handed to the worker that performs encoding. When the worker is done with the encoding task, it returns the results back to Amazon SWF. In this case, it can perform the encoding, place the encoded video, say in an S3 bucket, and provide the URL of the S3 bucket back as a result to Amazon SWF. SWF records that the encode task is complete together with the results of that task. Now there might be cases where tasks might time out or tasks might fail. That is, a worker has picked up a task but couldn't execute the task and return a result specifying that the execution failed. In all these cases, Amazon SWF will notify the decider that something has happened to a task that was previously scheduled. The decider can make decisions such as retrying a task, or it might decide to give up and just complete the workflow execution with a failure code. When the decider looks at the execution history, it sees that the encode task is now complete, and as per the application logic, the next task is to add DRM protection. So it returns a decision to Amazon SWF, asking SWF to schedule a task for DRM decision. SWF adds that to the DRM task list and also records that a new task has been added to the task list in the execution history. It then hands the task over to the worker that performs DRM, and this worker might take a while to perform this DRM task. But what this means is that during this time, other executions can be running, and the decider and the worker for encoding can be processing those executions. When the worker for adding DRM completes, the results of that task are recorded in the workflow execution history, and then the decider is again notified that the execution history has changed. The decider now looks at the execution history and figures that the encode task is complete and the DRM task is complete, and there is nothing else to do as per the application logic, so it completes the workflow, which is also recorded in the execution history. And as I mentioned before, Amazon SWF maintains a separate history record for each of the executions, and it can scale to a huge number of executions, wherein several executions are running in parallel, and the tasks for all of them are managed and tracked by Amazon SWF. So a little more detail into what Amazon SWF provides. The most important thing, or two of the most important things that Amazon SWF provides is reliable, non-duplicated delivery of tasks and consistent state management across distributed components. So one of the fundamental problems that we've seen developers have with queuing systems is that sometimes they might get duplicates, and there are very few guarantees about how tasks are delivered. SWF guarantees that the same task will not be handed to two different workers, and also tracks what happens to the task once it's been scheduled and once it's been picked up by a worker. There is built-in queuing in Amazon SWF, and SWF also gives you control over how tasks are routed to workers. You can set many different kinds of timeouts, such as a timeout for the time that a task has been scheduled to when it's been picked up by a worker, also timeouts for the entire execution of a workflow, and all these timeouts are tracked by Amazon SWF. As I mentioned before, SWF consistently maintains the state of the system so that you don't have to. What this means is that the execution state need not be recorded by your decider or by your workers, and that effectively makes them stateless. And what this also means is that you can scale them and also replace them when you need to. SWF tracks each of these executions on the task independently, and it makes them available, the status of those tasks and also metrics about those tasks and workflow executions available both through visibility APIs and through the management console. For long-running executions, Amazon SWF provides durability in state storage. So if an execution is running for about a year and tasks are not happening on a continuous basis, SWF keeps the state of each task that has happened so that when the next task needs to be scheduled, maybe 6 months from the previous task, you can always go back to Amazon SWF to look up the state of that particular execution and make decisions based on that. So here's a general flow of how you would build an application using Amazon SWF. This isn't a strict flow. There are many of these functions that you would perform maybe in a different order. But in general, when you look at an existing application or a new application that you're going to be building, you would want to separate out the application flow logic from the actual activities that need to be performed by your application. You then set up certain constructs in Amazon SWF, like domains, and you also register workflow and activity types. Domains are a very simple mechanism to group some of these constructs that you register with SWF. When you define workflow types and activity types, there are certain configuration parameters such as default timeouts that you can provide when you register them. But the key thing to keep in mind is that you're not telling SWF the flow of your application. When you register a workflow type and activity type, you're free to use them. You're free to use activity types in different workflows. The entire flow logic of your application is encapsulated into the code that you write for your decider and not through any definition that you provide to Amazon SWF. Then you have to build your workers and deciders and the workflow initiation code as we previously saw. Since you manage the workers and the deciders, you have complete freedom in how you deploy them and how many of workers and deciders you deploy. Once you've deployed and started your workers and deciders, you can start one or more executions of a particular workflow type through Amazon SWF. As these executions continue running, and even after they complete execution, you can view them in the console. Within the AWS Management Console, you'll find a tab for Amazon SWF where you can perform many functions. You can manage domains and types. So in addition to using the APIs to register domains and workflow and activity types, you can also manage them through the console. The fundamental purpose of the console is to help you view and work with your workflow executions. In the console, you can drill down into details about each workflow execution and each of the tasks that were executed as part of that workflow. You can also zoom out to see aggregate metrics about the number of workflows that are run in a particular time period, how many of them were successful and how many failed. You can also look at metrics such as how many activity tasks are outstanding. And this can help you with figuring out how many workers and deciders you need to run. And you can also use the Management Console to look at workflows that are completed and perform some basic statistics on things like, how many workflows failed in the last 30 days, or how many workflows were run of a particular type were run in the last 90 days. Let's talk about some of the other features that Amazon SWF provides. Oh, sorry. Timers are a very important function that helps you perform actions in the future. You can schedule timers, and Amazon SWF will keep track of the timer, and when it fires, it will notify the decider that a timer has fired, at which point the decider can do several actions. For example, it can schedule a new task when it notices that a timer that was set has fired. Using signals, you can build applications that can respond to external events. For example, you can process user commands to pause or terminate a long-running workflow using the signals feature. When you start workflow execution, you can associate tags with them. Tags help you group and search for your executions, and markers allow your decision logic to place checkpoints in the workflow execution history that you can look at later to drive decisions. So markers really, at any point in time, you can set a marker in your workflow execution history, and that is recorded in the history and available to your decider for taking any future decisions. Child workflow executions help you structure your application as a hierarchy of workflows. And what this really means is that a parent workflow can spin off many child workflows and can track each one of them independently, but things like the failure status of a child workflow execution are also available to the parent workflow execution, so that it can either spin off new child workflow executions or schedule new tasks or many such things. You can also provide input data to your workflow and pass custom data between activities. Both the input and the results of the execution of the activities on the workflow are persisted in the execution history. So the execution history is a complete record of each execution, including all the input data that was passed, all the intermediate results that were generated, and the final results, including the failure status. Task lists, as we saw before, also provide the ability to route tasks to workers. Amazon SWF will, by default, create task lists to route tasks to your workers, but you also have full control over in terms of creating your own task list and assigning workers to poll on those particular task lists. As we discussed before, Amazon SWF keeps track of workflow executions that have completed. In other words, it archives the workflow execution history and provides the same visibility into the workflow execution, whether it's ongoing or it has completed. And you get to configure how long each workflow execution needs to be retained by SWF. In addition to the implementation of SWF APIs in the AWS SDK, as you would expect from any AWS service, you will also find the AWS Flow Framework as part of the AWS SDK. Using this framework, you can easily write your applications that involve complex conditional logic and also applications that require remote execution. The Flow Framework helps you build applications that involve such distributed processing and asynchronous invocations without having to know about Amazon SWF. So what the framework does is it abstracts many of the mechanical tasks of interacting with Amazon SWF, such as polling, scheduling tasks, and the remote execution that happens in the execution of those activities. All this is abstracted when you use the Flow Framework. It also makes it very easy to program complex dependencies. So to asynchronously execute an application step, you simply make normal synchronous method calls. The Flow Framework schedules the tasks for those calls that correspond to those calls and also tracks the execution of that particular method, which might actually be executing in a different data center. You can also express dependencies simply by passing the output of one task as the input of another. And you can handle remote failures that happen during task execution as standard exceptions in your code. The Flow Framework is open sourced on GitHub, so we encourage you to take a look and also perform and provide contributions to the Flow Framework. The Flow Framework is currently available in Java, and we are working on making it available in more languages. And a point of clarification here is that the AWS SDK is, of course, available in many more languages, but the Flow Framework is currently available only in the AWS Java SDK. As I mentioned before, pricing for SWF is purely on a pay-as-you-go model. It depends only on how many workflows you run, what you do when you run these workflows, how long you run them, and for how long you retain them. When you start workflow executions, they are charged at the rate of $1 for 10,000 workflow executions. And different chargeable actions, such as scheduling tasks, setting timers and markers, all these are charged at the rate of 25 cents for every 10,000. One thing to note here is that each of these workflow executions and the tasks, they are tracked completely by SWF, and the state for all of them is managed in a consistent manner by SWF. If your workflow executions run past a day, then you pay 5 cents a day for every 10,000 workflows, and the same rate applies when you retain workflow executions. Let's take a simple pricing example. This workflow that I'm looking at, that I'm taking as an example, is the same one that we looked at when we saw how Amazon SWF works. So for example, let's say in a month, you are encoding 25,000 video files, and each of these workflows run for 12 hours, and the execution history is retained for 2 days. So starting the 25,000 workflow execution costs $2.50, and scheduling 10 tasks per workflow. So this is a slightly more complicated workflow than the example we looked at before. Earlier we had 2 tasks, and now we have 10. And scheduling these 10 tasks and tracking them through SWF costs $6.25. Running 25,000 workflow executions actually costs nothing because they all complete within 24 hours. And if you choose to retain them, based on the retention period that you pick, and in this case I'm assuming 2 days of retention, you pay 25 cents for that. And that's a total of $9 for running these 25,000 workflow executions, managing the state, being able to recover from failures by relying on the state that SWF keeps about these executions, and actually being able to look at the trace of the execution after the execution completes. All this costs $9 in this example. In different use cases, you fully control the costs that you incur, and we work hard to ensure that these costs align with the key benefits that you get from SWF for these different usage scenarios. So when you're performing short-running application executions, you will want to look at the number of executions that you run, the application steps that you execute for each execution of your application, and the number of days that you retain the execution trace, and we assume primarily for debugging purposes in this scenario. When you are using SWF to implement long-running business processes, again, you'll want to look at the number of workflows that you start, the number of days that the workflow runs for, and the tasks, timers, and markers and signals that you use as part of your workflow design. And finally, the number of days you choose to retain these executions, primarily for auditing or for some analytics. Even though we have only recently announced Amazon SWF, it's already being used in a wide range of use cases. Some customers like NASA use SWF to drive MapReduce workflows and also manage distributed cron jobs. NASA also uses SWF for their content management applications. Partners such as RightScale have built infrastructure automation solutions on top of SWF by layering existing workflow frameworks on top of the foundational capabilities provided by SWF. And also, several teams within Amazon and SWF and AWS use SWF for implementing key business processes, web application backends, and a range of applications including media encoding and content delivery. Using the foundational capabilities that SWF provides, there are endless possibilities in the kinds of applications that you can build in a scalable, cost-effective manner. I want to highlight one use case of Amazon SWF, and this is by Sage Bionetworks. If you look in our detail page, you will also find a full case study of how Sage Bionetworks uses Amazon SWF. Basically, Sage Bionetworks uses SWF to build their collaborative computation platform for biomedical research. There are several tasks that happen on the data sets that are available for medical research. First, the data sets need to be curated, and noise has to be removed from these data sets. Once the data sets have been curated, they are stored by the Synapse platform and then made available for analysis by different scientists. All of these analytic pipelines are managed through Amazon SWF. And using some of the features in SWF, Sage has built a platform that can use resources both in the data centers and on the Amazon cloud. Using the task list feature that we discussed, they can perform controlled task routing and prioritize the various analytic tasks that need to be performed and hence use the resources effectively. Since some of this analysis takes a long time to run, they use the durable state management function of SWF to support these long-running executions. And using the visibility APIs provided by SWF, they are able to integrate SWF and the state of their workflows back into their console so that they can provide a custom view of these workflow executions to their users. And also, SWF, as we discussed before, supports many different programming languages. And in this case, while the decider logic is written in Java, many of the workers that perform the actual analysis by running different algorithms are written in R, which is popular in the scientific community. We're really excited about Amazon SWF, and we're looking forward to the innovative applications and solutions that you, our customers and partners, will build on top of SWF. There are many ways for you to get started. You can look at the console, and there is a sample walkthrough that's available that will take you through the various steps of building and running an application with SWF. And once you log into the console, you'll find a button to launch the sample workflow, and that will take you through the various steps using a sample application for image processing. There's also a bunch of samples that are available as part of the Flow Framework. So these are samples that are available in the AWS SDK. So if you download the SDK, you can look into the code for these samples. You can modify and run them, and you can get a feel for many of the features that you can use with SWF and the Flow Framework. Pricing for SWF also includes a free tier. This free tier is available to both new and existing customers on a monthly basis. And many of your small applications can actually run entirely within this free tier. So we encourage you to start building your applications with SWF and see for yourself the different kinds of powerful applications you can build. Finally, there is a forum that's available where you can send us your technical questions, and we'll be happy to answer them. So that's the end of my presentation. Now we'll start our question and answer session. And before that, just want to leave you with our detail page, link to our detail page, where you can find more information on also our use cases and some of our technical documentation.
So we've got question, auditable periodic execution, does this mean a schedule cron mechanism, something like Quartz? So if you look at the systems like Quartz, they have two components. One is library, which allows to create schedules and convert those schedules to timers, and then a persistence component, which executes those timers. And simple workflow supports timers natively and persistence for those timers and guaranteed execution and other features like visibility into them. We don't provide a scheduling library because we expect that being implemented in the decider. It is pretty straightforward to implement decider that takes, for example, Quartz library and uses a scheduling component of it to generate delays for timers, and then write decider with it. We are planning to provide an example in Flow Framework in coming weeks doing that. So practically, if you have any scheduling mechanism, any library which can, in any language which can take schedule and convert it to delays, you can implement decider using that library.
Hi, this is Rick Sears. I'm going to take our next question. And the question asked was, are deciders people or are they objects? And the way we see this is that a question about what are the options in implementing a decider. As we covered in the presentation, the decider can be implemented in a lot of different ways, but the decider itself would be a system process running on any number of hosts that can run either in EC2 or even in your data center behind your firewall. So the decider would be a system process processing information that gets through the tasks returned to it from simple workflow. But the decider can include people in the processing of a workflow execution. And the mechanism by which you can do this is by scheduling an activity that might be picked up, say, by a user who's logged into a web page, who sees information from the scheduled activity displayed to them on the web page, and is able to make some determination of what should happen for that activity, and then maybe click on the web page and respond to the activity, which would go back into simple workflow and back to the system component decider running on another server to make a decision about what should happen next.
The next question we've got was, is any visual designer available for workflow definitions? So we don't provide visual designer. We're providing a service, but most of the existing visual designers generate workflow definition in some external format, for example, XPDL in XML format, or I think DeepL and others. And it should be possible to create deciders which interpret that workflow definition and execute logic according to it. I prototyped, for example, XPDL decider, and it was pretty straightforward task, especially if you use Flow Framework and existing library which parses the workflow definition. So we expect that there will be integrators who write integrations of existing different workflow designers to be able to run on simple workflow.
Hey, this is Shrikant, and the next question we're going to answer was about how long between activity scheduling and task execution does it take. And one of the primary goals when we designed the system was that this needs to be very, very quick. Once an activity is scheduled, we hand it out very quickly. It depends on your poolers also. If a pooler is already available, the task is handed out pretty much quickly, instantaneously in milliseconds. And typically, that's why we also implemented long polling, because we hold that connection for a long time, like 60 seconds, and if a task arrives in between, it's handed over to the poller right at the time. We don't have any guaranteed SLAs at this point of time, but you can expect this to be in the order of tens of milliseconds on a normal basis.
Hi, this is Rick again. So the next question we're going to answer is a question, we actually got a couple questions about data. And one of the questions was does data need to be stored within Amazon, or can it be local to the process? And also, how do we pass data? And the idea is that data passed in and out of the workflow or between the decider and the activities is intended to be smaller in size than what would normally be processed by the activity during its execution. So in the example we talked about video encoding or other types of applications that actually process potentially a large amount of information, that data most likely will be stored either on premises within your corporate network, stored in a database or in a company's file server, or actually that data could also exist within Amazon. Simple Workflow doesn't require that the data processed by activities reside within our other Amazon Web Services. But Simple Workflow does take information as part of the scheduling activity that can be used as references to that data. So for instance, if you wanted an activity to process a specific file as part of its execution, you could pass the URI to the activity as part of the input data during the decider scheduling. And that could give information to the activity, which would be a general use activity, to know which file it should pick up and process. And that file, again, could be pulled from S3, or it could be processed from a file server within the corporate network, or come from a variety of different places.
So we've got a couple of questions about how you control rate of execution of activities and deciders, and also should you specify the exact number of activity workers from the decider? No, the basic idea is that task list, they have semantic which is pretty similar to the queue. So how you can spawn any number of workers which poll for given task list, and then we practically implement a load balance across them, tasks across them. And so it's up to you how many workers you run for given task list. It allows you to, as you can, through our visibility API, you can get metric, the queue depth, number of outstanding tasks in a given task list. You can even implement automatic auto-scaling of workers if you run into the backlog situation. So other question is about rate control. We don't provide any rate control on task list on the server side right now, but it should be possible to limit the rate of, so practically you need to control it on the client. There are various ways to do that. For example, if rate is not very high, you can have leader election and elect a leader, and then let this leader to poll for given task list and control a rate locally. If you need higher rate, you certainly can allocate buckets of those rates. But I think most important point here is that scalability, as most tasks and activity and decision tasks are stateless. If you need to scale your application up, you just increase number of workers, and you need to change the architecture of your application.
Okay, this is Shrikant again here. The next question I'm going to take is regarding how should long-running tasks be handled. And there are three things. First of all, there is no limit on how long the task can run. And there is a limit on how long a workflow can totally run, which limits how long a task can run, but that's 1 year. So you can have pretty long-running tasks running. And we provide a few facilities here. The long polling itself, the 60 seconds timeout that Balan has mentioned, is the time a long poll is held. Once the activity is passed on to any activity worker, it can keep working on that particular activity for however long it takes to complete it, and pass back the information when it has completed the activity. The two things that we provide which helps you with this long-running tasks. One is what we call as heart beating. A long-running activity can keep heart beating with the service, saying that it's still working, and then we have a specific timeout for that. If we don't receive a heartbeat within that timeout, we assume that activity has timed out, and then we schedule with the decider. So heartbeats are very helpful for for long-running activities because it helps you to provide the right kind of timeouts, which facilitates you to write the applications in a more robust way. The other thing is long-running, the worker which picks up the task need not be the one which replies back as completing the activity. What we do is we just pass a token to that worker, and it can pass to some other worker to complete the work and come back to the service with a token saying that the activity is completed. So it's not like a single thread that's waiting for an activity to get completed.
So we've got a question about do we provide ability to abort timeout activities and change workflow execution path based on those error conditions. So Decider has full control over execution path. And as far as activities, we provide multiple timeouts. First time, when activity is scheduled, execution of activity requested by Decider, we put in task list. So there is a stated timeout which we call scheduled to start timeout. So how long activity task can reside in the task list before being timed out. So if your worker is down, then this timeout usually kicks in. Then after worker issues long poll and gets the task, we start another timer, and then we have start to complete timeout. If task is long running, and especially if it has unpredictable time to run, we have we support heartbeat functionality from the activity, and you can you just have to specify heartbeat timeout. So for example, if your activity can run up to a day, but it can fail any moment. For example, you're processing a huge batch file. You can heartbeat every few minutes, and the activity will time out as soon as the heartbeat is missed. You actually can even use it to implement some sort of leader election using this mechanism. And then we also have a timeout on from the schedule to completion, just to get some of those schedule to start and start to complete timeouts. As far as activity cancellation, as activities, as simple workflow never sends information directly to activities. Activities poll for information. We use heartbeat to notify activity about cancellation. So if activity heartbeat returns if it was canceled flag. And then if activity can clean its state and then notify that it was canceled, and then Decider can take next action. For example, abort the whole workflow or just go to different code path.
So the next question we want to answer was a question about specifically about the limit on the number of timers in a workflow, but I'll also point to other limits that we have within the service. So if you look at our FAQ, we document the actual numbers for these limits, but specifically for timers, there is a limit on for a number of open timers, 1,000 open timers per workflow execution. So if you have multiple workflow executions running in parallel, each workflow execution will have its own limit on the number of open timers. And when I say open timers, I mean timers that have been started that are pending firing, but have not yet fired. And so if I want to do more than 1,000 timers in a workflow, I can, but at any given time, I can only have 1,000 open timers within that workflow execution. So once those timers fire, the Decider can create additional timers. And as I also mentioned, you can have more than 1,000 across multiple workflow executions. This is also true for other aspects of the workflow execution, like the number of open activities, the number of open child workflows. And again, you can look at our FAQ to find out the specific numbers for each of these different use cases.
This is Shrikant back again here. I want to answer two questions here. One was about other languages for Flow Framework, and can Decider be written in any language? I'll take the second question first. The Decider can be written in any language because SWF is primarily a web service. You can interact through SWF through any language. We provide SDKs in certain languages, which makes it easier to write it. But Flow Framework is specifically available in Java. In fact, it is open source, available on GitHub. Flow Framework currently is available in Java, but we plan to write in other languages too. We have not finalized the list and the dates for that, as we are seeing the customer interest in which languages they would prefer the Flow language to be available. But most probably the first language we'll be going to do after Java would be Ruby. But we may change this plan based on the customer demand. But primarily, deciders and workers could be written in any language. It is neither restricted to the Flow Framework or any specific language. You can write them in any language you want. The next question I wanted to answer was regarding retention. There was a question about what is retained, where is retained, and each time you execute a workflow, the workflow history, which Balan was mentioning, primarily contains all the activities that have happened, all the tasks that have been accomplished as part of this workflow. This includes the activities that have been scheduled, the timers that have been scheduled, the markers that have been initiated, and also all the data that has been passed between tasks. All this is stored as part of the workflow history. And when the workflow is closed, it is stored, all this information, the workflow history primarily, is stored for you so that you can retrieve for a maximum of 90 days. So the retention is primarily the workflow history and everything related to it after the workflow is closed.
Yes, this is Balan. There were a couple of questions about, basic questions about writing deciders and activity code. So the question was, will users have to write both decider and activity code? Yes, when using SWF, we want to give users complete control over both the execution of the activities and also the application flow logic. So developers will write both the decider and activity code. However, it's very easy to wrap existing code that you might have and even existing legacy systems that you might have by simply writing an adapter that talks the SWF APIs or uses the Flow Framework, and on the backside talks to your legacy system or existing code. There's also a question about why the logic is separated in the decider. So one good reason for you to think about the application flow logic separate from your activities is that you might want to plug out different activities and replace the implementations that you have for them, whereas in general the application flow logic, which might involve some conditional logic that also uses some dynamic runtime state, all of this can be encapsulated into the decider code. And it also gives you the strength to use several programming languages. So your workers can be implemented in, say, Ruby or Python, whereas your decider code might be implemented in Java, or it might be implemented in a different modeling framework, which is adapted to use SWF. There's also a question about pricing in terms of what are the chargeable actions. So scheduling tasks, setting timers, setting markers, and sending signals, these are all counted as chargeable actions. And they are all charged at the rate of 25 cents for 10,000 of them. And there is also a free tier allowance for them. There's a question about charges for long-running processes. So if your execution completes within 24 hours, there are no ongoing execution charges. So in that case, you pay for starting the workflow execution and also for the various chargeable actions that you perform during the workflow execution. If your workflow runs for longer than a day, then in addition to those charges, you pay for every day that the workflow execution runs. And the benefit you get from SWF is that you're able to query the state of the application at any time. And if you choose to retain it, the same benefits are available to you even after the workflow execution completes.
Hi, this is Rick again. So we had one question, which was, I guess, a clarification about the requirements for activity heartbeats. So heartbeating in activities is not required. We don't specify or require that an activity while it's executing be heartbeating the service. you can actually schedule and execute an activity without a heartbeat timeout, which is one of the timeouts that Max mentioned previously. So in that case, the activity would run, and the only timeout that would apply would be the timeouts from when the activity started to when it completes, or from when the activity is scheduled to completion. So heartbeat timeouts are not required. But it is definitely recommended for any activity that runs a long enough period of time. You would probably not want to wait until, let's say it's an hour-long running activity. You don't want to wait an hour to know that your activity stopped executing within the first 10 seconds. And so heartbeating is definitely recommended and fully supported by the service. And we had another question, which was a question of what type of information needs to be passed to Simple Workflow if I wanted to contact a private service. I would imagine the example would be contacting a service that's, say, internal to a company's network. Simple Workflow, the activity to contact this private service could be running anywhere. It could be running in EC2 if that private service for some reason was exposed to the internet, or if the private service was only exposed on your internal network, the activity could be running within the corporate network. And to allow for that activity to contact that private service, most likely the information that you'd pass through Simple Workflow would be something like the URI or endpoint and port information to contact that service. You could pass, say, a reference to credentials, but it obviously wouldn't be recommended to pass the credentials themselves through Simple Workflow. You'd probably want to manage the credentials locally on the hosts where the activities are running so that you can protect those credentials that are necessary to contact the private service.
Okay. So we're at the end of our webinar, and there were some questions about where the slides can be downloaded and if the audio would be available. Yeah, we'll make them available for download, and we will send out an email to all the participants for this webinar with a link to that download. And thank you for all your questions, and we hope we got to most of them. We'll look through the questions again, and the ones that we run out of time to answer, we will incorporate them into our frequently asked questions. Thank you again for joining, and we look forward to seeing the various use cases in which you will use SWF. Thank you.